St. Joseph's College for Women, Autonomous, Vishakhapatnam. Welcome to St. Joseph's open web-based learning platform, So E-Learn, for a soulful and enriching e-learning experience. Good morning, dear students. My name is Dr. P. Padmavati Devi, working as Assistant Professor in the Department of Physics of St. Joseph's College for Women. Today my class is for 2nd BSc, 3rd semester, Optics. I am going to discuss the Unit 1, Aberrations. The contents which we are going to discuss today is Introduction to Aberrations. What is aberration? What are the causes for aberrations? How to minimize the aberrations? What is chromatic aberrations and the types of chromatic aberrations? Achromatism and minimization of achromatism. So what are the objectives of studying aberrations? So by studying aberrations, you will gain deeper understanding of optical systems. You will try to understand how optical systems form images and what are the factors that affect image quality. You will also study about the different types of aberrations and how to minimize these aberrations. It also analyzes the optical systems in designing better systems. It helps us to design and optimize them for various applications. After completion of the chapters, let us see what are the outcomes. We will try to understand what are optical aberrations, where we will identify and classify the different types of aberrations. And we also analyze the causes and effects of these aberrations. We will try to study the techniques to minimize the aberrations in lenses and mirrors. How to solve the problems related to aberrations, and we'll try to apply to real world scenarios. Let us see about the introduction to aberrations. Actually, what are aberrations? Aberrations are a broad category of phenomena in various fields which involves deviation from the expected or normal state. Actually, the term aberration can be applied to different disciplines including optics, astronomy, biology, psychology, and even Dungeons and Dragons. Even though we have different disciplines of aberrations, here we will discuss only optical aberrations. So we will see what is an aberration. In the first image, you can see the image of a distorted portrait of a person. The distortion includes color fringing, particularly green and magenta, which suggest chromatic aberration. Means the face is slightly misaligned, maybe due to motion blur, which can be caused while the photo was taken, leading to image corruption. Or this can happen due to different wavelengths of light failing to converge at the same point, which is causing color separation, which can also be caused due to lens imperfections or poor focus, which is causing chromatic aberrations. In the second image, you can see a comparison of the same structure with columns and windows. The top half of the image is very clear, while the bottom half, severe chromatic aberration can be seen. The bottom half of the image shows rainbow-like colors, blue, magenta, and yellow around the edges of the object, which is due to where the lens fails to focus the different wavelengths of light at the same point, which is causing color misalignment. So by seeing these two examples, we can see what is an aberration. So aberrations are nothing but these are the deviations or the defects observed in actual size, position, shape and color in the image of an object formed by a single lens are called aberrations. So what are the cause for aberration? You can see in the diagram A, chromatic aberration in a simple lens. The white light enters the lens and gets refracted at different angles. So the red and the violet light, after refraction, they do not focus at the same point, which results in color fringing or a blurry image, because the lens fails to converge or bring all the colors to the same focal point. So this is an example of what longitudinal chromatic aberration, where the different colors focus at different distances along the optical axis. In the diagram B, you can see this aberration is corrected by using an achromatic lens. So a specially designed achromatic lens is used to correct these chromatic aberrations. Achromatic lens is nothing but the lens combination of a convex and a concave lens made from different types of glass, which makes sure that the refracted light or the different colors focus at the same point. So whatever the light that is entering this achromatic lens, you can see in the figure, is focusing all the colors at a single point, which is reducing what color fringing and improving the image sharpness. So these aberrations can be minimized by using achromatic lenses. These defects are mainly due to light and due to optical system. Due to light means if the light is not monochromatic, then the image becomes multicolored and the defect is known as chromatic aberrations, which means it consists of what? Multiple wavelengths instead of a single wavelength, because we are saying it is a monochromatic. And due to optical system, even with a monochromatic light, several defects in shape of the image are formed, which may be due to limitations in lens designs which affect the shape and quality of the image. So they are known as monochromatic aberrations. So what is a chromatic aberration? The chromatic aberration occurs due to dispersion of the white light into different wavelengths which refract at different angles. You can see in this figure a convex lens. Through this convex lens, a white light enters the lens. Instead of converging at a single point, the rays are separated based on their wavelengths. So the red light, which is having longer wavelength, refracts less and focuses farther from the lens, which is denoted as FR. And the violet light is of shorter wavelength, refracts more and focusing closer to the lens, which is denoted as FV. We have two types of chromatic aberrations. First one is longitudinal chromatic aberration and the second one is lateral chromatic aberration. So let us see what is longitudinal chromatic aberration. In the left diagram, you can see a white light enters the convex lens from point O. Then the lens disperses the white light into different colors: violet, red. Here in this figure we have shown only two colors, violet and red. So the violet light has a shorter wavelength and bends more, focusing closer to the lens at IV. You can see the other color, red color, has a longer wavelength and bends light, focusing farther from the lens, which is represented as IR. So the different, here you can see both the red light and the violet light are not focusing at a single point. They are focusing at a different points. So the difference between these focal points is called longitudinal chromatic aberration, which is given as IR minus IV. In the second figure, you can see the right one. The white light enters the lens. It shows how the different wavelengths, red, green and blue, focus at different distance along the optical axis, which is causing a blurred image instead of a sharp image. So what is a longitudinal chromatic aberration? The formation of the images of different colors in different positions along the axis is known as longitudinal chromatic aberration. The main cause, the different wavelengths experience different refractive indices in the lens material. So what is a lateral chromatic aberration? In this figure, you can see a white light is passing through the lens. Due to dispersion, different wavelengths bend by different amounts. The violet light, V represents the violet. Violet light bends more than red light and causing them to focus at different position on the image plane. So instead of a single point, the image spreads at different colored components along the lateral directions. So the positions AV and AR shows violet and red light focus for point A and similarly BV and BR for point B. So which causes color fringes around the edges of an image, which may be due to of blue or violet color on one side and red on the other side. So what is the lateral chromatic aberration? Is nothing but the defect in the images of different colors formed of different sizes perpendicular to the axis is known as lateral chromatic aberrations. It is observed that the image of the red color than the image of the white color is larger. So the magnification is given by the formula size of the image by size of the object. You can see a photograph or an image of the chromatic aberration. This photograph is taken with a high quality lens and a wide angle lens. This photo with a high quality lens is not showing any chromatic aberration, but the photo with a wide angle lens is showing a visible chromatic aberration at the dark edges on the right. So as we know, the chromatic aberration means what? The different colors does not focus at the same point, which is causing a distortion of the image. What is an achromatism? Achromatism is the property of an optical system that eliminates or reduces chromatic aberration, which ensures that the different colors focus at the same point. So how these chromatic aberrations are minimized? Chromatic aberrations are minimized by using a chromatic doublet. A chromatic doublet is nothing but a combination of a convex lens made up by crown glass and a concave lens made up by flint glass, which are arranged coaxially. So these two convex lenses made up by the same material are arranged coaxially at a distance of d is equal to f1 plus f2 by 2. So achromatism is nothing but a property which reduces the chromatic aberrations and sees that all the different colors focus at a single point. All the images in this video are taken from open educational resources. Thank you.